A decimal is an alternative way of expressing a fraction. So we can interconvert a fraction to a decimal, and of course, the decimal into a fraction. Let us take an example. For example, if I have the fraction 3/7 to be converted into a decimal, we can do the long division process. So let's go. By doing the long division process, we have the number to be divided into, which is 3, and then the divisor, which is 7 out there. So this is the long division process. 7 divides into 3. That's not possible, but we force it to happen by saying 7 divides into 3, that's 0. And then we append a 0 to 3 to make 30, and compensate by introducing that decimal point right there. Now 7 divides into 30, that's 4 times. By multiplying, we get 7 times 4, that's 28. And subtraction, 30 minus 28, that gives us 2. We append the 0 to be able to continue. 7 divides into 20, that's 2 times. That's 7 times 2 multiplying, 14. And now 20 minus 14 gives us 6. Append the 0 one more time to continue. 7 divides into 60, that is 8. 7 multiplied by 8, 56. 60 minus 56, that's 4. Now we append the 0 to even continue. 7 in 40, that's 5. 7 times 5, that's 35. 40 minus 35 gives us 5. Append the 0 to continue. 7 goes in 50, 7 times. 7 times 7, 49. And when we do the subtraction, 50 minus 49, let's continue in this area, 1. We append the 0 to be able to continue. 7 divides into 10, that's 1. And 7 times 1, that is 7. 10 minus 7 gives us 3. And you see we're back to that same point, because now if we append a 0 to be able to continue, and we divide 7 divides into 30, gives us 4. And then the pattern will repeat itself. 4, 2, 8, 7, 5, 1. Another round of it. 4, 2, 8, 7, 5, 1. That will keep repeating itself. Another round of it. 4, 2, 8, 7, 5, 1. So it will keep going, and that will be endless. This is a recurring decimal, an unending decimal. So this fraction, it means the fraction 3/7 can be converted into the decimal form 0.428571 recurring. So a decimal is an alternative way of expressing a fraction. A decimal is actually an alternative way. That's very good. So, we can also do the interchange, and that is pretty much easier, converting decimals back into fractions. So let me get these traces out of the way. So let us see how to convert. For example, I take the fraction 0.125, and now we want to convert this into the equivalent fraction. The technique is simple. Write only the significant digits without respecting the decimal point. So simply 1, 2, 5. Place that writing upon 1, and then ask. Find out how many digits after the decimal point. 1, 2, 3 digits after the decimal point. And that means we're going to have 3 zeros written by the side of the 1. 1, 2, 3. And now we can reduce. This is the fraction that actually represents 0.125, but we can reduce it to its simplest form. When a number ends in 2 and 5, it means 25 can divide to that number, of course. 2 and 5 at the end of the number, 25 can go. Now 25 divides into 125, that's 5 times. 25 divides into 100, that's 4 times. And 25 is 0, that's 0. So 5 can still divide. 5 divides into 5, that's 1. 5 goes in 40, that's 8. And that implies that the fraction 0.125 is equivalent to the decimal. Is equivalent to the decimal. The decimal 0.125 is equivalent to the fraction 1/8. That's right. Very simple. We can take on another. Okay. Supposing we have a digit, a non-zero digit before the decimal point. 1.05. How do we convert this into the equivalent fraction. Simply, we write all significant digits without including the decimal point. And you can see all digits here are significant. 1, 0, 5, without the decimal point. And then place this writing over 1. Now ask, how many digits after the decimal point? Of course, we have that. 1, 2, which means we can append 2 zeros right here. So 40 and then the second 0. This is the fraction equivalent to the decimal 1.05. Now we can divide through by common factors. Of course, by inspection, 5 can divide. 5 goes in 10, that's 2 times. 5 goes in 5, that's 1. And we can do the same thing in the denominator. 5 divides into 10, that is 2 times. 5 divides into 0, that's 0. And that means there is no common factor any longer. So it means the fraction 1, the decimal point, the decimal 1.05 is equivalent to the fraction 21 over 20. Or we can have the mixed form. 20 divides into 21, that's 1, the remainder 1, placed over the original divisor, which is 20. I've been able to convert the decimal into the equivalent fraction. All right. So this is how to convert decimal into the fraction. Let us move further by looking at operations involving decimal. So the traces we have to go, and then we can see next area. Let's go. Addition and subtraction of decimals. How do we do this? Addition and subtraction of decimals. In order to add or subtract decimals, we must make their decimal points align. So alignment of the decimal point is the first thing to do. Align the decimal points. Then the operation can be carried out smoothly. So first, establish an alignment of the decimal points, which means they have to be arranged vertically. So if we have a situation where we need to add 1.321 added to 13.26, added to 128.346, then we have to align the decimal point. So let's do that together. Solution begins. 1.321. For the next one, 13.26, the decimal point must align with the first decimal point. So we can write the remaining digits. After the decimal point, we have 2 and 6. Before the decimal point, we have 13, 3 there, 1 there. Alignment of the decimal point. The next number is 128.346. Align, start with the decimal point. After the decimal point, you have the digits 3, 4, and 6. Then before the decimal point, you have 128. So 8 there, 2 there, and of course 1. Operation addition. Let's go for it. So we want to add up these digits right now. So let's rule off. All right. And now we start the addition from the far right-hand side, the extreme right. From the far right, add corresponding digits. 1 plus 6, that gives us 7. 2 plus 6, 8. 8 plus 4, that gives us 12. We write 2 and take over 1. 3 plus 2 is 6. That's 6 plus 3 is 9. 9 plus the incoming 1, the spillover 1 is 10. So we write 0 and spillover 1. 1 plus 3 is 4. 4 plus 8 is 12. 12 plus the incoming 1 is 13. And we write 3 and spillover 1. 1 plus 2 is 3 plus the incoming 1, that is 4. And now 1 plus 0 gives us 1. And this is our final answer. Beautiful. For subtraction, the same thing. Supposing we want to do the subtraction, 98.675 minus 26.34. Why are we doing this? When we have a digital electronic device like the calculator, the electronic calculator can take care of all of this. Why are we doing this? We need inner skills. In standard tests like the SAT, the UTME, and equivalent test, the calculators are not required. They're not allowed. And therefore, you must make sure you have these skills. So let's do the subtraction once again. So we're going to have 98.675 to subtract alignment of the decimal point, remember. So after the decimal point, you have 3 and 4. Then you have the 6 right there. Operation subtraction. Let's go for it. Now 5 minus 0, because when there is no digit written, it means we can replace it with a 0. There's a 0 digit written, not shown. 5 minus 0, that's 5. Once again, notice that subtraction is from the far right-hand side, the extreme right. 7 minus 4, 3, and it is between equivalent digits or corresponding digits. 6 minus 3, 3, and decimal point position shown. 8 minus 6, and that's 2. And finally, 9 minus 2 gives us 7, our final answer. Very simple. And let's do one more. Let's show one more example of subtraction. I have to take these traces away. Let's show one more example of subtraction of this house. So supposing we have 13.2813 minus 9.412. Supposing we have this. So let's go with the alignment of the decimals. The larger number, 13.2813. To subtract, decimal point must be made to align. Then we have the only digit says 9. Then we have 4, 1, 2. Operation subtraction. Let's go. Equivalent digits. 3 minus 0, as discussed earlier. We're starting once again from the far right. 3 minus 0, that's 3. 1 minus 2 cannot happen. We force it to happen by borrowing 1. Taking over, these are numbers in base 10. So by the side of that, making 11. 11 minus 2, that's 9. And now this reduces to 7. 7 minus 1, that's 6. And now we have 2 minus 4. We force it to happen by borrowing 1, making 12. 12 minus 4, that's 8. Decimal point respected. This has reduced to 2 because of the borrowing. So it means 2 minus 9 cannot happen. So 1, 12 minus 9, that gives us 3. That's right. Very simple. So that's how to carry out a subtraction of decimals. Okay, let us take this away and proceed to the next area, which is multiplication and division of decimals. Now we take the first one. In order to multiply a decimal, we must carry out multiplication without considering the decimal point position. At the end of the operation, the decimal point is then finalized. Supposing we have the number 21.32 to be multiplied by 1.03. Supposing we want to carry out this multiplication table, now we go in layers. Let's go. We write 2132. We don't need to show the decimal point in subtraction. Multiply by 103. We don't need to show the decimal point. We may not necessarily show it. It's optional. We may not necessarily show it. So let us begin digit by digit, starting from the far right-hand side. Let's go. So if multiplication must start from the last number on the right, let's go. Now 3, let's use the digit 3 to go around. 3, we have to multiply all the digits we see here. 3 times 2, that is 6. You can see we're starting from 3, so the answers begin under the 3. 3 times 3, that's 9. 3 times 1, that is 3. And finally, 3 times 2, and that would be 6. Beautiful. This result was obtained by using 3. Now we use 0. 0 times 2, that gives us 0. So all the answers under 0 will be 0. 0 times 3, and that is 0. 0 times 1, and that is 0. And of course, 0 times 2 gives us a 0. Now, we will see in due course that anytime we have a 0 digits in multiplication, it is not significant. So we can actually carry out multiplication without showing the zeros. I'm going to show that in another example. It's the turn of the 1. 1 times 2, that gives us 2. 1 times 3, that gives us 3. 1 times 1 gives us 1. And of course, 1 times 2 finally gives us 2 right there. Now it's time to add all these results, equivalent digits or corresponding digits. 6 plus all the zeros here, that's 6. 9 plus 0, that's 9. 3 plus 0 plus 2, that's 5. 6 plus 3, that's 9. And of course, 0 plus 1 is still 1. And 2 plus 0, and that is 2. And now it's time to fix the position of the decimal point. Only now, at the end of the multiplication, we can fix the position of the decimal point. That's right. Now, how many digits in the previous form? How many digits after the decimal point? Let's go for them. How many digits really? 1, 2 in the first number, and then 2 more in the last one. So a total of 1, 2, 3, 4. Now we count from the right-hand side to determine the position of the decimal point. Let's go 1, 2, 3, 4, and then we can fix the position of the decimal point. Our final answer. Very simple. Very, very simple indeed. So this is how to do the multiplication of decimals. Let us see another example to seal it up. Supposing we want to multiply 381.2 multiplied by 4.008. Look at that. Want to carry out this multiplication, we simply ignore the decimal point positions and write straight away 381.2 to be multiplied by 4.008 without showing the decimal point position. Now, operation times, of course. So let us begin. The usual practice, the far right-hand side. The significant digits here are the 4 and the 8. So we're not going to show the result of zeros. 8 times 2, that's 16. Let's write 6. And spill over the 1 digit to the next result. 8 times 1 is 8. Plus the incoming 1, that's 9. 8 times 8, 64. 4, we take 6 over. 8 times 3, 24. 24 plus 6, and that's 30. So we can write 30. Now, these 2 zeros are insignificant in the multiplication process. We're going to bypass writing them. These 2 zeros, we're not going to do anything with them. Now, let us go and multiply with 4, so long as we can bring the result of multiplication of the 4 underneath the 4. Underneath the 4. So we have 1, 2, 3 underneath the 4. That's right there, underneath the 4. So 4 times 2, that's 8 underneath the 4. 4 times 1, that is 4. Then 4 times 8, 32, that is 2. We take 3 over into the next result. 4 times 3, 12. 12 plus the incoming 3, and that is 15. Very simple. Now, addition of digits in corresponding position. So let's go and add 6 plus nothing here, that's 6. 9 plus nothing here, that's 9. 4 plus nothing showing there, that's 4. And 0 plus 8, 8. 3 plus 4, that's 7. And these digits will be written again. 2 plus 0, that's it. 5 plus 0, that's 5. And of course, 1 plus 0, that's 1. Now, how many digits in the original multiplication after the decimal point? So we have to count them. So let us see how many of them. After the decimal point here, we have 1. After the decimal point here, we have 1, 2, 3, making a total of 4, as we can see. 4 digits after decimal point. It's time to fix the position of the decimal. Let's count 4 digits from the far right-hand side. 1, 2, 3, 4, and the decimal point is going to be right there. Very simple. our final answer. Very simple. So that's how to multiply decimals. Now the process of division of decimals. Let us take a few examples. Now for standard tests, the division of decimals will be such that we can rely on our multiplication table. All we need is the multiplication table, mastery of the multiplication table. And I want you to see one of my videos where I discussed the general requirements for handling calculations, effectively. And the multiplication table is part of the essentials. Okay, let us see the first example. Supposing we have 1.28 divided by 3.2. 1.28 divided by 3.2. How do we deal with this? Let us write in the form of a fraction. So this is going to be rewritten as 1.28 divided by 3.2. And now we have to take the decimal points, take care of the decimal points. Now we find out how many digits after the decimal point in the numerator. Let's count, and that will be 1, 2 digits. So we record that 2 digits after the decimal point. How many digits after the decimal point in the denominator? Just 1. So only 1 digit. And now we are going to shift the decimal point in the numerator and denominator such that we don't have the decimal point any longer. So we have the greater number of digits after the decimal point in the numerator. That's 2 digits. So we set out to write 1, 2, 8 without showing the decimal point position, which means we have moved this decimal point position to the very end right there. 2 shift. And therefore, we have to also do 2 shift in the denominator. 2 shift in the denominator. The first shift goes to give us 32. And now we have to give a 0 to compensate for the remaining shift. So 128 divided by 320. It's easy to handle this. Let's divide by 8. 8 can go, of course. 8 divides into 12. That's 1. Remainder 4. 4 by the side of 8 makes 48. 8 divides into 48 6 times. 8 divides into 32 4 times. And 8 divides into 0, we have 0. Now 8 can still divide. 8 divides into 16, that's 2 times. And 8 divides into 40, and that's 5 times. So our final answer is actually 2/5. And you can now convert this back to decimal form by saying 5 divides into 2 cannot happen. So 0, append the decimal point, and force it to happen by giving a 0 to this to making 20. 5 divides into 20, and that is 4. Very simple. Now we have our final answer in decimal form. Let us take the second and final example of this. Supposing we have 7.29. That's right. And we are going to divide by 0.027. Step 1, let's write as a fraction. So we have 7.29. So this is going to be written as 7.29 divided by 0.027. Now the decimal point shifts. Well, let us determine first the number of digits after the decimal point in the numerator and in the denominator. Let's go. So there are 2 digits after the decimal point in the numerator. So let us write that down so that we can remember. And in the denominator, there are 1, 2, 3 digits after the decimal point. So the greater number is 3 in the denominator. That means we're going to shift the decimal point position 3 times in both the numerator and the denominator. Let's go for that. So let us do 3 shifts of the decimal point position in the numerator. That will make us go 1, 2, and the third one is, of course, a 0. So we have 7,290. Divided by 3 shifts, of course, 1, 2, 3, and that's outrightly 27. 729 is a familiar number. 27, of course, 9 can go. Let us divide with 9 very quickly. 9 divides into 72. That's 8 times. 9 divides into 9, that's 1, of course. And 9 divides into 0, that's 0. 9 divides into 27, that's 3 times. And we can continue the division. 3 can divide. 3 divides 1. 3 divides into 8, that's 2 times. 6, remember 2. 2 by the side of 1, making 21. 3 divides into 21, that's 7. And 3 divides into 0, and that's 0. And we have our final answer, of course, 270. Let us take note of it. Division of decimals is best. Operations with decimals are best handled by using the electronic calculator, of course. But this video is made for those who will take standard tests like the SAT, the UTME, and other similar exams where the calculator is not welcome to the exam hall. And of course, maybe in some of these tests, you have a non-standard calculator that can be used. But what a beautiful thing it to be for you to be able to carry out these operations with little mental exertion, right? So that's all about it. Let us take these cases away and now take 2 important steps. So you need to subscribe to this channel. I don't want you to miss videos when they are produced on this channel. This channel contains inspirational quotes, lectures in science subjects, and of course mathematics. So subscribe and turn on the notification bell so that you know when a new video is produced or released on this channel. Thank you for being part of this session. My name is Temple AK. I'm your regular coach. Keep up the practice and remain solid. Bye-bye for now.